minutes time. Starting in 3, 2, 1.
So good evening, ladies and gentlemen. I invite you to hear the magical story of a wondrous molecule called ozone. And to get ready for this, I would like to invite you to take a deep breath with me on the count of 3. 1, 2, 3. Great. What you have in your lungs, 20% is this here, oxygen. This is not yet ozone, but it's the raw material for ozone. We have a question? Yes, you can breathe out now. Good. We need a bit more of magic. We need a bit of UV light, and here you see how ozone is born. 3 oxygens form a molecule. And such a marvelous birth must lead to great powers. And ozone indeed has powers. Some of those you have heard in the radio when they talk about urban pollution. These are not the powers I want to talk about tonight. I want to talk about the light powers of ozone. The ozone that is above us in the skies, protecting us from hard UV radiation from the sun. And it is quite little actually that is up there. If you bring it down to Earth, it's only 3 millimeters a layer. So this fragile equilibrium was disturbed in the last century. And in the next minutes, you will hear how this happened, how we found out, and what we are doing about that. So it began in 1929 when a wizard called Thomas Midgley Jr. was experimenting in his laboratory and trying to make new molecules. And what he did, he took some carbon, fluorine, and chlorine and made a group of chemicals that were called chlorofluorocarbons. They were quite a cool substance because they were on the one hand non-toxic, non-flammable, very stable, highly interesting to industry. So actually you could talk about it was attractive witchcraft. So what could you do with these molecules? You could, for example, make some refrigerators to fill it in, that's the refrigerant liquid. It was good as a propellant and hairsprays. Highly specific solvents could be made out of it, and replacing some of the atoms with bromine. Actually, also you could use it as a fire extinguishing agent. So at this moment, dear audience, I want really to apologize. I am aware that this slide is particularly attractive to the gentlemen here in this room, and I tried hard to come up with an equivalent slide for the ladies in here. But again, I have to apologize. All I found in my gallery of wizards were nerdy schoolboys, beardy old men, and horrible freaks. So I prefer to go on talking about chlorofluorocarbons, which were, as I said, very interesting to industry, making a lot of money of it. But at the same time, there was some problems up in the sky. There was a storm brewing, and there were 3 wizards on the quest of enlightenment who found out that there was something going on which was not good at all. Paul Crutzen, in his laboratory, analyzed how the ozone could be destroyed by naturally occurring molecules. Murray Molina and Sherwood Rowland looked deeper into their crystal ball, or should I better say, into their crystal clear minds, to find out that the chemical that Midgley Jr. devised in his laboratory was a potential ozone killer. They made experiments in their lab, and what they found out, they wrote it into a magic book in 1974. And the story goes about like this. Chlorofluorocarbons rise up in the sky, sun dissociates them, forming a chlorine radical. The chlorine radical tears apart ozone, but gives it off quite quickly again to another oxygen radical, and ready is ozone destruction. Dear audience, it is so easy to get a Nobel Prize. Interestingly, by the way, the color green was given to chlorine well before the bad characteristics of chlorine in the atmosphere were known. Green, just the same color, of all those bad guys that appear in scientific literature. Well, maybe not all of them are bad. Good. So 10 years later, what has been observed in the lab was found also in nature. Joe Farman and his group made observations in Antarctica and found that ozone was decreasing. And this was also confirmed by the satellite of Nimbus 7 from the North American Space Agency. And the picture that was taken about in the year '84 looked about like this. A hole bigger than North America on over Antarctica. This, of course, was a shock to humanity, and humanity decided to get together in a council and do something about it. They decided and talked, and they met first time in a city called Montreal in Canada in 1987. From henceforth, these agreements that were made were called the Montreal Protocol, and decided to phase out those bad chemicals and replace them with new ones that had less chlorine. So this again was good for industry, of course, because they were making the substitutes. The effect was very quickly found for example, here at Jungfraujoch in Switzerland, at the monitoring station, one could see how the concentrations stopped to increase and decreased afterwards. The problem was that the substitute chemicals were increasing. So, and these were still damaging the ozone layer. So the council met a second time, this time in the city of Copenhagen, and decided to phase out also those chemicals and replace them by a new one, which is the hydrofluorocarbons. No chlorine anymore. That was good. And the effect was very nice, well, for industry, of course, but also for the Earth, because you can, as you can appreciate here, the ozone layer, meanwhile, still increasing until about 2006. After that, it was slowly closing. And if we are lucky, in 2050, we will be back to normal. So just almost more than half a century of work on that. So what you could say now, you could say, okay, you have heard that. This is an old story, isn't it? Well, let me tell you something new. This last chemical, that was the hydrofluorocarbons, had problems as well. Because these chemicals are quite hardly changing global climate, about a couple of thousand times as strong as carbon dioxide. So what happened? The council got together a third time. Well, no, it's not. It is getting together this very year, 2016, together to try to reduce also these climate killers. So you may ask now, who is it, the wizard of ozone that I announced you with my first slide? And some of you may have already guessed. There is not one, there are many wizards of ozone. There's the one apprentice who did some foolish experiments in his lab. There are the scientific wizards who found out what was going on and showing it to the world, raising awareness. And there are those wizards who meet year after year in a convention and discuss and with diplomacy, deliberating of how to save the ozone layer, how to save global climate. And this actually is quite a hard job. A lot of negotiation, because everybody comes here with national interests, with national economic and political interests, and all this hard work could have been easily avoided, in my opinion. Yes, if we had listened to what a German poet said about 200 years ago about doing chemical experiments and doing magic without the proper risk assessment. With this, I thank you very much, and goodbye.